Hello everyone, my name is Ain and today I will explain about message passing. What is message passing? Imagine you have two friends who want to exchange information. They can't directly access each other's brain, so they need to communicate through message. In computing, message passing is similar. Processes can directly access each other's memory, so they exchange message to communicate and synchronize their actions. Let's talk about synchronization. Synchronization is enforcing mutual execution. This means only one process can use a critical section at a time. Next, we have communication. Communication allows process to exchange information. This is essential for process to share data and work together efficiently. How does message passing work? Message passing works by sending message between processes. These messages are sent using primitives. Send, receive. Message passing is versatile and work with distributed system as well as shared memory, multiprocessors, and uniprocessor system, ensuring proper message exchange. Communication between processes involves synchronization. The receiver cannot receive a message until it has been sent. When a process executes the receive function, two outcomes are possible. The first outcome is no waiting message. If no message is waiting, the process can either wait for a message to arrive or continue executing without receiving. The second outcome is message available. If a message has already been sent, the process receives the message and continues executing. Blocking send and blocking receive. In blocking send and blocking receive, both the sender and the receiver are blocked until the message is delivered. This method is often referred to as a rendezvous. A rendezvous occurs when both the sender and receiver process meet at a specific point to synchronize and exchange a message. Blocking send and receive allow for tight synchronization between processes. This means that process A and process B work together very closely, coordinating their action precisely. Understanding non-blocking send and blocking receive. In non-blocking send and blocking receive, the sender continues after sending the message, while the receiver waits until the message arrives. Useful for sending multiple messages quickly. This combination is highly useful as it allows quick message dispatch to various destinations. In non-blocking send and non-blocking receive, neither the sender nor the receiver waits. Direct addressing. With direct addressing, the message itself contains the identifier of the recipient process. This identifier is like a name tag on the mail that tells the mail carrier exactly where to deliver it. Now, let's talk about the receive primitive. This can be handled in two ways: explicit addressing, implicit addressing. This method, like direct request for a message, it works effectively for concurrent processes that are closely working together. And the second method is like having a callback when you receive a message. The receive primitive has a source parameter. This parameter holds a value once the receive operation is complete, signaling that the message has been received. In indirect addressing, messages are not sent directly from one process to another. Instead, they are sent to a shared data structure called a queue, which can temporarily hold this message. These queues are also known as mailbox. Think of a mailbox as a storage space where one process can drop off a message and another process can pick it up later. Next, we will see what four processes that have indirect communication. First, let's look at one-to-one communication using mailbox. In this setup, a single process sends a message to a mailbox, and a single process retrieves it. Next, we have many-to-one communication using pods. Multiple processes can send messages to a single pod, which are then received by one process. Now, let's consider one-to-many communication with mailbox. One process can send messages to multiple mailboxes, which are then received by different processes. Lastly, we have many-to-many communication with mailbox. Multiple processes send messages to multiple mailboxes, and multiple processes retrieve them. Lastly, we will explore the general message format used in process communication. As you can see, message consists of two main parts, the header and the body. First, we have the header, which contains important information for message handling, such as message type, destination ID, source ID, message length, and control information. Lastly, we have the body, which contains message content. That's all from me. Thank you for watching this video.